Okay, then let me start. Actually, your second unit is over. Almost the second unit is finished. So I will start the first unit. Okay. Second unit, this one is probability, and first unit is the partial differential equation. Okay. Uh, this unit consists of partial differential equation, first order partial differential equation, second order, and homogeneous, linear, homogeneous, and non-homogeneous partial differential equation, and so on. Okay, and then let me start the partial differential equation. Actually, I think all of you know about differential equation. Okay, what is differential equation? Tell me what is differential equation.
Which involves two or more variables, ma'am.
It may involve two or more variables and derivatives. Okay, if the equation consists of derivatives also, differential coefficient also. Okay, suppose like as d2y dx square plus twice dy dx plus 5y plus suppose 0. Okay, this is an ordinary differential equation. Actually, there are two types of differential equation. First one is ordinary differential equation, and other one is partial differential equation. Okay, in ordinary differential equation, actually it is also a differential equation which consists the two or more variables. Okay, and with their differential coefficient. Okay, then we use suppose dy dx. Here in that case, the dy, x is independent variable and y is dependent variable. Okay, one independent variable and another is independent variable. Okay, and we take the derivatives of the dependent variable. Okay, and this forms the differential equation. This is actually ordinary differential equation. We have already studied those type of equation, and these are called ordinary differential equation. Okay, and in case of suppose partial differential equation means what? It is also a differential equation which consists partial differential coefficient of a function of variable. Okay, it consists partial differential coefficient. Okay, in case of ordinary differential equation, suppose we differentiate dy dx differentiate with respect y with respect to x. Okay, here but in the partial differential equation, it consists two or more variables. Okay, first one is suppose one is two or more variable, and we consider the two variables is like as independent and other one is dependent variable which depends these two variables. Okay, and see the definition: an equation involving partial differential coefficient of a function uh, of two or more variable is known as the partial differential equation. Okay, if a partial differential equation contains nth and lower order derivative, suppose it contains nth derivative. Nth derivative means what? Suppose the dy dx, d2y dx, okay, and d3y dx cube, okay, and so on. We consider suppose nth derivative. Nth derivative means what? D n y dx to the power n, called nth derivative. Then it is said the nth order partial differential equation. Okay, and I think all of you are know about the order and degree of differential equation. Okay, and yes or not? Are you know about the order and degree of differential equation?
Yes,
Yes,
ma'am.
ma'am.
Then tell me what is the order of a differential equation?
Highest degree, ma'am. No.
Highest degree.
Like,
Highest power of the derivative is called order. Okay, highest power of the derivatives. Suppose you consider d2y dx square plus 6 dy dx. Okay, highest power of the derivative. Okay, here d means what? D is the derivative. Okay, if we write d2y, then it is order, then highest order is what? 2. So the order of that equation is what? 2. And degree is what? The highest power, highest power of the highest derivative. Okay, highest power of the highest derivative is called degree, and highest power of the derivative is called order. Okay, here also this is same. The degree of the equation is what? Highest exponent of the highest order. Okay, and uh, there is also, in case of ordinary differential equation, you study linear differential equation, okay, and homogeneous differential equation and non-homogeneous. All the types, I think all of you are known, okay. But here partial differential equation, the definition is same, but here we consider our partial differential coefficient like as partially. We differentiate partially. Okay, if we suppose differentiate x, then y is treated as constant. Okay, but in case of the ordinary differential equation, it is not treated as constant. But in case of partial differential equation, when we differentiate, suppose the del, here we use the symbol del to use the partial differential equation. If we write del x, del y del x, then del y del x means what? We differentiate y partially with respect to x. In that situation, if we differentiate with respect to x, then we consider y as a constant. Okay. Later on, I will see you and see the here, but all the order and degree, the definition is same. Okay, the definition is same, but here we use the partial differential coefficient. Okay, for ordinary differential equation, like as we consider the linear differential equation. Okay, in case of linear, what we do, in the linear differential equation, it is what? If the degree is 1. Okay, if the degree is the 1, then it is if it is suppose first degree, then in the dependent variable, then we call it is linear differential equation. So here also the partial differential equation is said to be linear if it is of first degree in the dependent variable and its partial derivatives, then it is called linear. Okay, and equation which is not linear, it is called a non-linear. Okay, remember this thing also. This thing, in case of partial differential equation, we usually use two independent variables. Here we use two independent variables. It consists two independent variables. Okay, but in case of differential equation, we consider only one independent variable. One independent variable and other is dependent variable. Okay, but in case of partial differential equation, we consider two, at least two independent variable. Which one? Which is assume as x and y. X and y are independent variable, and z. In some books, it is also written, suppose u, z, u denotes for a dependent variable which depends on the value of x and y. Okay, suppose if we consider in partial differential equation, you have to consider at least two independent variables. Okay, but in case of differential equation, you have to consider on at least one independent variable. Okay, difference is this one. And you can also consider n independent variable, and if we consider n independent variable, then equation is look like as x1, x2, x3 up to x, and also n1 dependent variable. Okay, here suppose we consider dependent variable z, and here if we consider nth independent variable, then the dependent variable z depends on this nth variable, independent variable. The value of z depends on this variable, nth variable. Okay, this thing remember that if partial differential equation we consider at least two independent variables, okay, and one dependent variable, okay. And here also we classified linear partial differential equation, homogeneous partial differential equation, non-homogeneous, and so on, okay. And see the definition is issued. Definition of, suppose we consider a single unknown u, suppose we consider only a single function involving u and its partial derivatives, then it is look like as this one, f of this one, f of u1 u1 denotes the partial derivatives with respect to x and y, okay. And this is also an another partial differential equation. Here see that we use del, but in case of ordinary differential equation we use d. D, small d represent what? Differentiation, okay. And del, when we use this letter, big letter del, this del used to denote partial differential equation, okay. In some cases it is written, suppose u1 or u suffix x. U suffix x also denotes the partial differential equation with respect to x. Suppose if we write u suffix y, then it is partial differential equation with respect to y, okay. When we write ux, okay, or you can write also u dash, ux, okay, these are partial differential equation. Del u, del x, these are, which denotes the partial differential equation, okay. Here see that this is a nonlinear partial differential equation, okay. Here it is nonlinear because of what? Here see that here the degree of this equation is what? The degree of this, although the degree of the equation is 1, but here see that these are product of two variables, okay. Del x square del t, okay. This is not linear, so it is not linear. Here see that one is 3, but here this one is del x square. It is not del x square, so it is not linear, okay. But here see that this one is a linear partial differential equation. Del 2u del t square, okay. Del 2u del x square. Here degree of this equation is what? Degree of this equation is 1, okay. Hello, hello.
Yes, ma'am.
Yes, ma'am.
Ma'am,
See the difference. Here degree of the equation is what? See example 2.
2 ma'am.
Degree.
2.
How can you tell that? Here order is 2, okay.
Degree 1, ma'am.
Degree 1. Order means what? Order is the highest power of the derivative. Here highest power of the derivative is 2, okay. So order is 2, second order. But degree means what? Degree means um, power of the highest derivative. Here highest derivative is what? 2, del 2, and power of this one is what? Power of this term is what?
1.
1. So degree is what? Degree is 1. So if the degree is 1, so we can say that this is a linear partial differential equation, okay. In case of linear, in ordinary differential equation also, the degree must be 1. Then in that situation you can say that this is linear, okay. In partial differential equation also, the degree must be 1, okay. Degree must be 1, and there is no term appears look like as this one. Here suppose that del y, del x square del t, but here this one is 3, but here this one is 2, okay. Here suppose if we suppose write del x square del t del y, then it is linear. Then this one will be what? 1 plus 1, then 3 will be, again we get 3, so it will be linear. Okay. Difference here, only remember that we use this symbol delta. Delta is used to denote partial differential equation. Okay, delta is used to denote partial differential equation. And in some cases we write, in some books this write book as suppose u suffix x. U suffix x, then this also denotes partial differential equation with respect to. Okay. And similarly, if we write del sorry, uy, then it is also partial differential equation with respect to y. Okay. And in some book is also write as suppose u dash. Okay, u dash, capital D. Okay, capital D and capital D dash, these are used to denote partial differential. Okay, remember that, don't confuse. Suppose see this one also. See this del u del t plus 2 into 1 plus x squared. This is also, here order is what? Equation order of this equation is what?
1, 1,
Order
1,
highest power of the derivative is here. What is the highest power of the derivative?
3,
3.
3,
3. So order is
3,
order is 3 and
1,
degree is 1. Okay. Here order, this is a third order partial differential equation with degree 1. So it is linear. Okay. Are you understand? Hello? Hello?
ma'am.
Are you understand?
Yes, ma'am.
A a partial differential equation is what? It if consists two or more independent variables. Okay, with
Yes.
partial differential coefficient, then it is called partial differential equation. Okay, if the equation this involves two or more independent variable with their partial differential coefficient. Okay, partial differential coefficient means this del. Okay.
Ma'am,
Hello.
what if the equation is in whole equation is in bracket and the bracket has some power? Then what is the order?
This one.
No, ma'am, suppose the whole equation is in bracket,
Whole
single bracket,
whole equation.
and it has some power.
Suppose it is look like as del u del v plus one whole power. Suppose are you say hello?
Yes, ma'am.
Suppose it is writer. Suppose del t plus y into 1 plus x squared into del x cube plus y whole power 2.
Yes, ma'am.
Okay? Are you say
Yes, ma'am.
this type of equation?
Yes, ma'am. Then what is the order?
Then you can break this equation. First, you have to break.
Yes, ma'am.
That break means you have to factorize. Okay, a plus you have to break this equation into suppose a plus b plus c whole cube formula. Okay. After that you have
Okay.
to break each term. Okay. Then see the after that see the highest power of the derivative. Okay, then the
Okay.
highest power
Okay.
of the derivatives is called the order, and degree is what highest power of the highest derivative. Here see that highest power of the highest derivative is, here see that highest power of the derivative is 3. Okay, this one,
Yes, ma'am.
and highest power of this derivative is what?
One, ma'am.
1. So it is first degree equation, first degree partial differential equation. So we can say that this is a linear partial differential. Okay,
Yes, ma'am.
can
Okay,
you
ma'am.
understand?
Yes, ma'am.
Okay, so remember this thing here in partial differential equation. You have to consider two independent variables. Here suppose x and y. Here x and y are independent variable, and u here sorry, here we don't use y, like we use the dependent variable as x and t. X and t are independent variable, and y is the dependent variable, and y depends on the value is what? X and t. Okay,
Ma'am.
in partial differential equation there are at least two independent variable, at least two independent variable must be there. Okay, and other one is dependent variable which depends on the, here suppose we consider the dependent variable like as u, and u depends on t and x. Okay, and see this definition, classification of first order partial differential equation. And first order partial differential equation, this denotes the first order partial differential equation. F of capital F of x y z a b, this denotes always equals to 0. This equation always denotes the first order partial differential. Okay, this always denotes the first order partial differential equation. Here suppose in some books it may be write as suppose x y u. In some books it may be look like as write as suppose u also. Okay, u also, then it is also a partial differential equation. This first order partial differential. Okay, and then here see that x y z, here x and y are independent variable and z is dependent variable. Okay, if this is a first order partial differential equation, and it is called semi-linear if it is linear in ab. Here ab are coefficient, ab are the coefficient of a and b, and if it is said to be semi-linear if suppose a b uh, are the function of x and y only. Okay, it's said to be quasi-linear if it is linear in a and b. Not this condition will be like this, suppose a and b are function of x and y only. If we omit this one, then we say that this is a quasi-linear partial differential. Okay, these are the definition. And non-linear, suppose it is the not suppose semi-linear, quasi-linear, then in that situation we say that this is a non-linear. Okay, and linear means what? If it is the first degree, and no suppose the product of two independent variable, that will not come. Okay, then in that situation we say that this is a linear. Okay, that the definition. If suppose if this equation comes, and you have to know that there is the first order partial differential. This equation represent first order partial differential. Okay, in some cases it in place of z, in some cases in some books it is write as suppose u. Okay, if we, then don't confuse it. This is the first order partial differential. Okay, and see this one. See this one. This one is also a first order partial differential equation. here x, y, z, p and q. We consider p and q. Okay, here in p and q, suppose p and q is what? Z, zx and zy. Okay, zx and zy. But here we consider a and b, which are function of x and y only. Here, that if we write, suppose it is write this one of this type. Suppose say if we write, suppose in place of p, if we write zx and zy also. Okay, then this also represent a first order partial differential. Okay, this one z equals to f of x. That means z is a independent sorry dependent variable which depends on the depend x and y. Here x and y are independent. Okay, suppose we write del z del x del here we differentiate z with respect to x. Okay, this one is suppose p and this one is suppose q and so on. So this represented by first order partial differential equation. It contains three types of variables. See that x and y are independent variable and z is dependent variable. Okay. Here p, q, r, s, t are partial derivatives of the dependent variable with respect to the independent. Uh, Remember these things we differentiate partially in the independent variable. Okay, we differentiate in the dependent variable set. Let me tell about the solution of partial differential equation. How can we solve? Suppose this one. These are some process. Suppose consider the first order differential equation, first order partial differential equation. Then where a and b are what? A and b are some constant. A and b are constant, and z is dependent variable. Then first you have to differentiate this one del f del x. Okay. First, you have to differentiate z with respect to x, and after that, differentiate z with respect to y. After that, put the value of a and b in this equation, and then you get the solution. Let us take an example. It will be clear. Suppose this one. Find a partial differential equation by eliminating a and b from this equation. Okay, see this one. This is an equation, and you have to find a partial differential equation. Eliminating a and b. A and b means what? Here a and b are constant. Okay, by eliminating a and b, we can obtain a partial differential equation. Here, see that first to obtain the partial differential equation, first you have to find del z del x. Okay, del z del x means here z is this one. Z is the dependent variable and z is defined in this way. And first you have to find del z del x. See this equation. Okay. Hello. Hello.
ma'am.
Hello. Hello.
Yes, ma'am.
See this equation. See this equation. How can we differentiate partially x, which is z plus both x and y. Both z is given in this way: ax plus by plus a square plus b square. Here a and b are what? A and b are constant. Okay, a and b are constant. First, the differentiate z with respect to x. So we write this one del z del x. If we write del x, then this means what? Differentiate with respect to x. Okay, differentiate z with respect to x. Here see that if we differentiate with respect to x, then we consider y like as constant. Okay, remember this thing. If we differentiate z with respect to x, then you have to consider y as a constant. Okay, if there are, suppose that there are three independent variables. Suppose you have to there is another suppose independent variable b of b x y, suppose c t also, t is a suppose dependent variable, sorry, independent variable. In that situation also, if we differentiate z with respect to x, then you have to consider y and t like as constant. Okay, so it will come as del z del x equals to a. Only a will become, because y is treated as constant. Similarly, if we differentiate this one with respect to y, then we consider x as a constant. Okay, are you uh, understand the understand the hello? Hello?
Yes, ma'am.
Have you understand? Have you understand?
Yes, ma'am.
Yes, ma'am.
Difference one with respect to x, then we consider y as a constant. After this, we differentiate z with respect to y, then we consider x as a constant. So this del z del y will be t. And after that, putting the values a and b in this equation, then you get that this equation is complete one, and this is the partial difference. Okay. Similarly, from this one also you can find a partial differential equation. First, you have to find what, if suppose z is this one, ax plus 1 minus a into y plus b. Suppose these are given, then to obtain a partial differential equation, first you have to find del z del x. Okay, after that find del z del y. Okay, after eliminating a and b, you can easily find the required partial differential. Okay, this one. Similarly, this one is an example. So z is defined in this way: x minus a whole square plus y minus b whole square. Okay, these are given. Then first you have to find del z del x. After that you have to find del z del y. Okay, and after that you can get this. These are what, by eliminating constant you how can we obtain partial differential equation. Okay, these are those. Okay, then let me stop today. This one, write this question also. Write this question. Hello,
Yes, ma'am.
write this question. Form a partial differential equation eliminating of this one. Try to find a partial differential equation for this one. Number one, z equals to f of y by x, and number two, z equals to x power n into f of y by x. Try to find this one. This is a homework.